Hey everyone, thank you so much for the kind introduction. And I work as a machine learning engineer at Weka. I've been associated with Open Source 101 for quite some while. It's been always like a pleasure to come and talk to you folks. I recently wrote a book which is known as Sculpting Data for ML. And let's begin. Today we'll discuss about some tools or toolkit you might need for open source or like open source tools for machine learning. So the last couple of years have seen an immense growth of machine learning in multiple domains, from influencing our shopping lists to cars self-driving themselves around the town. Unquestionably, machine learning is the most used and abused subdomain of artificial intelligence presently. It is being wielded in improving healthcare, advancing warfare, scrutinizing your resume, to determining your creditworthiness. It also helps in creative aspects like creating music and meaningful lyrics, to even synthesizing pictures and videos of non-existent people and so on. So it's kind of like everywhere. And regardless of our fascination or loath of it, it is influencing our decision-making powers and is dominating our lives heavily. To describe, for someone who needs like a brief introduction, machine learning would encompass enabling computers to learn on their own. And this power of spotting patterns on their own in like big data, without the requirement of actually programming each and every rule, is the biggest edge these decision-making systems have over the others. Researchers keep traversing unexplored territories of machine learning, whereas according to experts, the businesses have just seen the tip of the algorithmic iceberg. According to Finances Online, $28.5 billion were allocated to machine learning worldwide in just the first quarter of 2019, which was like almost 2 years back, and is expected to grow $40 billion by the end of 2025, where it just started from a meager $1.3 billion in 2019. So the growth has been exponential. Even in the number of companies, almost 50% of the companies worldwide have either been exploring or planning to do machine learning in the near future. So definitely it's a good skill to have. Even the number of startups, small startups focusing on pure machine learning services are having like a 14 times rate of increase currently. If you're like a mobile user, 97% of mobile users use machine learning trained voice assistants like Siri, with a 40% search now just powered by voice. Advancement in the software aspect has also led to a projected growth of $120 billion global sales of AI-powered hardware by the end of 2025. Even as I'm setting my new house, I'm planning on like all these machine learning powered hardware, right from like doorbells and motion sensing lights and so on. So all these things, they work on a certain aspect. And it's very necessary to understand that machine learning is the future, but is it magic? Definitely not. This is the entire workflow that someone should focus on when you're doing like machine learning, right from like defining a problem statement to developing an intuition of how machine learning can tackle the problem and challenges. Then begins like sourcing the data or fabricating our own data set. Then you process the data set and perform feature engineering. Then you have to like define the metrics, appropriate metrics to measure the success of the intelligent solution that you might be proposing. And then you choose the appropriate model and learning algorithm to address the problem. Then goes deploying the model and monitoring the prediction, maintaining new streams of data and refreshing model parameters. And it's kind of like an iterative process that goes on. So to have a successful career or to have a successful journey in future technologies like data science, machine learning, and analytics, you need a combination of basically two complementary skill sets. The first that we talked about was the first half of the workflow, which is an instinctive understanding of the problem. Like how do you define the problem statement formally with like a proper input and an output, like what do you expect? An instinctive understanding of the data, like what the data is, what are the essential data signals and so on. And the other part is a practical expertise with relevant tools, which mostly comes in handy for the last half of the workflow, which is when you source the data set, you do feature engineering, and then you like create the model, deploy the model, and so on. So while the first half, which is developing an instinctive understanding of data, is a long-term and immersive endeavor. Basically, you just keep on learning every day. Like as you change domains, you have to like keep on learning. Ads may have a different domain, like movie recommendation may have a different domain. So you have to like learn according to the domain. But then for the tools, you can always start learning because tools pretty much remain the same regardless of the domain or regardless of the problem statement you have in mind. So let's start about the toolkit, especially in terms of open source, which might help you. Uh, so the first is programming languages. What kind of programming languages are good to know? So instinctively to our mind comes like Python, and then the second would be R. Even though Python was initially designed and is still used as like a general purpose programming language, today it's one of the most popular languages for machine learning and data science. Native data scientists favor Python because it's minimalistic, intuitive, readable, and has a vast repository of libraries for specific purposes. You can use Python for dataset curation, for data analysis, feature engineering, modeling, visualization, basically most of the things that would come in that workflow. It's a popular language with high quality machine learning and data analysis libraries, as we talked about. So one of the biggest advantages I would say Python provides is its model development and the fastest prototyping. Because of the amazing libraries you have, it helps to quickly prototype. Let's say you have an idea in mind and you want to like show quickly on like a small data set how it would perform. Python comes in handy like really then. The second language that we usually talk about is R. R is a statistical computing language, and it is favored more by data analysts and statisticians who are trying to make their way into ML. Like Python is known for its like predictive accuracy and is more prevalent in artificial intelligence circles. R is mostly common where people do more of like statistical inferences, and definitely is one of the most popular languages for data analysts. So statistics, visualization, data analysts, for data analysis, R is a popular language, but if you want like a wholesome language, I would definitely recommend Python. Now, once you're done with the languages, then comes the analytical and visualization tools you need to analyze the data, to visualize the data, because you don't suddenly like jump into machine learning frameworks. You have to like build it step by step. So the first tool that usually like, and one of the oldest tools I would rather say is SQL. So from database to data science is something of a journey that SQL has seen. The most common tool the data scientists apply for extracting data from both relational and non-relational databases is SQL, because most popular kind of data is the tabular data, right? It helps you write structured queries to extract data basically and see different views of data. And it's a very fundamental skill every machine learning engineer, every budding data scientist should actually have, because when you don't see the data by yourself and when you don't immerse yourself fully into the data, it's very hard for you to like make predictive inferences and brainstorm and come up with new ideas. On similar lines comes Pandas, which is a Python software library primarily used in data analysis and manipulation of the numerical tables and time series. It is of high performance and it's very easy to use. So I would say, again, this is a very handy tool. Like all the tools that I'm talking about are very handy and like kind of like must-haves. I will also talk about some alternatives that might come in. So Pandas is something that you should learn. It is for importing, cleaning, manipulating data as a pre-preparation for building machine learning models. It enables data scientists to perform complex data analysis workflows. Yeah, basically you can do analysis by converting like CSV, JSON, TSV files, or even SQL databases into like kind of like a data frame, which is inherent to Pandas. So any format of in which the data exists, you import it into Pandas as like a data frame. And then it works like an object. You can combine it with so many other different tools and just to enhance performance and support a collaborative work. So after Pandas comes Matplotlib. So Matplotlib is nothing just like a visualization library. So previously, the two that we talked about, like SQL and Pandas, are more of like analysis. This is more for visualization. You can do like 2D plotting, 3D plotting, contour plotting, line, scatter, polar, image, histogram, like most of like the plots you can do to visualize how the data looks like, because it's very necessary to also see like the percentage of like labels, positive labels, negative labels, to see how the feature is hydrating and so on. So again, Plotlib, you can easily integrate with Python toolset, and you can use with other libraries like, that we'll talk in the future about, like Numpy or PyTorch and so on. Again, multi-platform data visualization library that you should be known of. You can say Cborn is kind of like an alternative, if or maybe just like an enhancement over Matplotlib, because it is for like more attractive data visualization. So it is again based on Matplotlib, but then if you want to like go one step further, it offers like a high level interface and more like customized themes. You could give like a color scheme and so on for visually enhanced statistical graphics. It also has the ability to accurately visualize data frames, which we talk like the Pandas data frames, which like inherently Matplotlib kind of like struggles with. So Cborn, like if you're just starting with machine learning and data analysis and visualization, you could choose one of them. But Cborn is just like one step ahead of Matplotlib with more like customized themes and high level interface for these statistical graphics. So now like the analysis tool, the visualization tool. Now let's go for some like rich interactive input output system where you can run your systems, like run your models, and just give an input, come with an output. And Jupyter is one such tool. So though it was traditionally used in academia as a notebook kind of tool, it actually is a notebook because it has like different cells. You write the input, you get the output, and like so on. It was used in academia to record research notes and computation findings. But today, Jupyter Notebook has found its place in like the entire data visualization realm. Programmers and ML professionals use Jupyter Notebook for various reasons like data cleansing, numerical simulation, statistical modeling, data visualization, and so on. The good part about Jupyter is it supports not only Python, like people usually think it supports Python, but it supports over 40 programming languages. And you can easily integrate with big data processing tools like Apache Spark and so on. It is very helpful for a collaborative work capability, so that you can ask people to collaborate with you on the same notebook. You just do like kind of like a link sharing. It is very rich in functionality and provides various use case scenarios. So one of the alternatives that I would like to talk about Jupyter is these days Google Collab. So Google Collab is also kind of like a notebook environment created by Google. But the only difference is it's kind of like on a cloud service, just like you have Google Docs and Google Sheets. There's a new feature known as like Google Collab, new product. It supports libraries like PyTorch, Keras, Tensorflow, OpenCV, again, that we'll talk about, but just an alternative to Jupyter. If you don't need the hassle to set up it all itself, you can just create like a small notebook on the cloud. So now that we've talked about all the tools that we might need to prep for, like have like a place where we can run, or like to do data visualization, and just like find out interesting patterns in the data yourself, like initially, let's come to like libraries and frameworks, which is one of the biggest aspect people think about when they think about machine learning, right? Like modeling, how do you create models and how do you run them? So let's talk about some libraries and frameworks. So the first thing that should, before even if you go for like those big heavy duty libraries and frameworks, it's important to know Numpy, which is like an extension package for kind of doing scientific computing with Python. Do quick arrow multiplications, divisions, multidimensional arrays and matrices, because most of the machine learning data is represented in kind of like vector format or array format, or like matrix if it's like 2-dimensional and so on. So it contains broadcasting tools for like Numpy to perform like linear algebra and like random number capabilities. So it is a very effective method, like container kind of storage for multi-dimensional generic data. And you can define arbitrary data types and quickly integrate with tons of databases. So it's kind of like all-in-one mathematical toolkit that you might need for especially to use in Python to like manipulate the data and do like quick scientific computation. Scipy is another alternative that you can consider. Though Numpy is like very popular. Now coming to actual machine learning modeling, one of the most beginner-friendly tools I would say is a scikit-learn. It's a multi-purpose Python library primarily used for data mining and analysis and modeling. It is used across all kinds of like supervised and unsupervised algorithms. It has one of the best, I would say, documentation and like lots of tutorials available online for use cases in like classification, regression, clustering, pre-processing, and model selection. So if you're just beginning out and you need to like try out different models, scikit-learn is the way to go, because that's what I did as well when I just got started. It is favored by those working in like simple things like spam detection, image recognition, text classification. If you just want to get your hands dirty with it, this is the tool to start. It's open source, built on top of Scipy, Numpy, and Matplotlib. So these are the three libraries it is based on to create that modeling framework. It's very simple, transparent, and the tools can be like widely adopted. So definitely something that one should check out. And next comes TensorFlow. You might have like heard a lot about it. It is like developed by Google and like currently being supported by Google. And then machine learning, it is for machine learning at scale. So it is a computation framework for building machine learning models. And they use basically it is for image recognition, text classification, natural language processing. And it kind of like mimics the anatomy of the human brain in terms of like neurons. I don't want to go deep into it because this presentation was like mostly projected as like tools you could get started with, and I wanted to like divide it. But it's like a very flexible framework for large scale machine learning. Another advantage of this framework is it works both for research and recurring machine learning tasks. Recurring would be, for example, you are at a startup and you need to serve like every second, like a request comes in. So it is very helpful in that and also very useful in academia. It can be used across various of computation platforms. It supports CPUs, GPUs, CPUs, and runs on any OS, and like variety of basically devices, from desktops to clusters to servers to mobiles and to edge systems. It even has like a TensorFlow Lite for machine learning for like smaller devices. Definitely something to look at if you're looking to get started with neural network and wanted to do machine learning at scale. With TensorFlow comes Tensorboard. I wanted to mention it in the visualization tool, but it's not something that is kind of like a must-have. This is a good tool for model training visualization, especially in conjugation with TensorFlow. It gives out like throws a summary data, observations about a specific model's operations being generated while TensorFlow is running, like live data statistics about the model. The model structure shown with graph allows researchers to make sure the model components are working fine and where they're located and if they're connected properly or not. So this graph visualizer, you can explore like different layers of user abstraction and so on. So definitely something if you're working with TensorFlow to look at. Did I miss a chat or something? Got it. So next comes Weka. Personally, I haven't used it a lot, just like checked it out as a tool per se. But I would say that if you're looking for a nice GUI kind of a thing for machine learning, definitely look at this. It accelerates the learning curves for people who are not confident in their coding skills, yet they want to do machine learning. This is something to look at because it has like tasks such as pre-processing, classification, association, regression, clustering, visualization, all those shenanigans, but with a nice graphic user interface, like as compared to this. So it is a tried and tested open source machine learning software that can be accessed through like a GUI and standard terminal applications as well. It is widely used for people who want to like teach to people who and for research and for industrial applications, and it has like a lot of built-in tools for machine learning. So definitely if you are someone who likes their user interface and are like just getting started and like super confident in their coding skills, this is something, for trying out machine learning for once. Now let's talk about some specific libraries and frameworks for specific tasks. For example, you are like heavily inclined towards real-time computer vision applications, image processing, video capture, and face detection, object detection kind of tasks. So in that case, OpenCV is like a cross-platform library that you can work on, again, open source, uh, specifically for that task. And again, if you're like looking for natural language processing tasks, to work with Python programs for human language. This is something like NLTK is a Python-based human language data processing platform that one can look at. It is a standard library for text processing and has many useful features, especially when you're doing like feature engineering sort of tasks, different types of text, sentences, word processing, speech tagging, sentence structure analysis, named entity recognition, text classification. I know I'm like throwing these stuff out, but it's good to know at least terms so that you can always look them up. Uh, the libraries are like free and they provide enough functionality for solving like majority of tasks. So now that we're done with say visualization tools and analysis tools, and even like the basic libraries you would need to get started with machine learning, like scikit-learn, TensorFlow, it's also good to look at the deep learning tools. So what are like deep learning tools would be? Deep learning is referred to as when you do like modeling with neural networks, but with more than like 2+ layers, your network becomes deep. Like technically it should be more, but yeah, that's how deep learning is defined. So in that case, sometimes it's necessary for you to have like pre-trained models, because you can, like warm start from it, get started from it. And there are specific tools which are developed just for, those kind of like deep learning tasks. So one of them is Keras. After TensorFlow, which we consider an all-purpose ML tool, and not for deep learning, because it has like grown since it was like developed as a deep learning tool, is Keras. It is for evaluation. It's cross-platform, open source neural network library, again written in Python. So that's why I said like Python is something that is very useful if you're getting started in machine learning and you just want to build a career in data analysis, better than R, in my opinion. I did start with both of them initially, but then obviously steered towards Python. Keras is built to enable fast, easy, and convenient deployment of deep learning models. It's very modular, minimal, extensible, and Python driven. It might be easy to say so, but when you start working with it, you would get to realize that it helps prototyping at like lightning speed. So you have a model in mind, you want to just like showcase, build like the first prototype. This is something to start with, and it can run on GPU, CPU, and support both recurrent RNNs and CNNs basically, as well as like a combination of both of them. On the similar front, we have PyTorch, and there's also a flexible and modular framework for AI and ML. It was developed by, currently supported by an AI research team at Facebook, and it's also used in computer vision and NLP. It boasts the ability to expedite experimentation to move models swiftly to production. Again, it has both Python and C++ interfaces and helps in like distributed training and extensive range of tools. Yeah, so PyTorch and Keras are one of the two most common deep learning tools that I know of and I've tried, and I would recommend people to get started with. Now comes the last half of basically like the last two parts of the workflow that we talked about. So you have built your model and you want to like deploy those in production. By deployment, I would mean like you want them to run like one after the other and then also serve in real time. And then you want like sometimes need like tasks to repeat, like online training kind of a thing. You need where as and when the new data comes in, it goes into the pipeline, feature engineering happens, like new features get formed like in the same rows, like new roles. And then basically like keep the task running. So that's when like deployment comes into phase. You have to like do kind of like resource allocation and so on. So the tools that usually come in handy, like one of them would be MLflow. It was designed to work with any machine learning library or algorithm and manage its entire life cycle, including experimentation, reproducibility, deployment, and so on. It is currently in alpha and it has like three main like tracking projects and models, like these kind of like three main components it has. Something that I've used personally would be TensorFlow Extended. Again, it's you can use in conjugation like TensorFlow, Tensorboard, and TensorFlow Extended. So TFX is an end-to-end platform for deploying machine learning pipelines when you're ready to move from research to production. It helps you create like a manageable pipeline with different components. It's developed by Google, and it provides a configuration framework and shared libraries to integrate common components. So the components that I'm talking about would be like, fetch data. So something like that, and you can always change the function inside of which how it fetches data. It might be like very easy to say so, but when it comes to it is very intense and something that is really helpful for production, even at like big scale companies for developing pipelines. So after you've deployed, sometimes you need to like, these are some additional tools that I would like to talk about when you have like lots of data. So Apache Spark is something for cluster computer programming and for big data analytics. It is favored because of its speed and easy to use and highly integrable across various platforms and data sources. So it's faster, more convenient, and basically you can perform everything in parallel. And that is where MapReduce also comes into place because it's heavyweight in data manipulation. It's a kind of like a programming model for big data processing on clusters. I didn't want to like go deep into it because I just wanted here to like share the names of the tools. Like that's what I was intending to. But if you're someone who works with big data, definitely try checking out Apache Spark and MapReduce programming model because it helps doing parallelizing computations across huge volumes of data, both unstructured and structured. So yeah, that's again coming back to the workflow. It is very easy to see workflow, but when you're just getting started with machine learning, people try to focus on this aspect of the workflow, like just when they're starting out, like defining appropriate metrics to measure the success of intelligent solution and choosing the appropriate model. Many times they end up forgetting that this is where you should actually be starting with, like sourcing the data and fabricating your own data set. Because if you don't have data, like the kind of data you input is how your model would perform, right? And processing the data, doing data analysis, data pre-processing, data transformation, feature engineering are like solely as important as the modeling aspect of it. Your model is as good as the data it gets. So in that, if you're interested in building data sets from scratch, like creating your own data set, be it for like fun purposes or to solve like a specific problem you have in mind. I recently wrote like a book with my co-author, which is known as Sculpting Data for ML. It is a hands-on book in Python and beautiful soup. So you'll get like code snippets and access to a GitHub repository as well. It tells you about significance of data in machine learning, identification of like relevant data signals. If you have like bundles of data, how do you like identify which is important and which is not? And end-to-end process of how to collect data and basically construct your own data set with Python code examples. And it also helps do feature engineering and data pre-processing. So if you're someone who's interested in this book is endorsed by leading ML experts. You might have heard of like Lawrence Morney from Google, Julian McCauley from UC San Diego, and Meng Ting from Microsoft. You can definitely check the book out. And with that, thank you so much for listening to me, and just wanted to share different tools. We can go on to questions if you like.
Great. So there's some questions in the chat for you, Jigyasa.
Yeah, sure, definitely. We are watching. Hi. Shambi says, hello from Colombia. Jigyasa enjoying the book almost every day. Hey, Shambi, thank you so much. Yeah, I saw on Twitter that you won the giveaway. So Todd did a giveaway in the open source meetup. So in case you're interested, everyone can check out the book. But yeah, thank you so much. Joan said, you look very familiar. Have you done some online courses? Talking about me, I've done like a couple of like open source talks and machine learning talks, and quite active on Twitter, if that you say so. But yeah, can we get the link for the slides? Definitely. I haven't like posted them online somewhere, but yeah, I can definitely share the links once I have, or I can ask Todd to maybe send it in the newsletter or something. Do you happen to have? Yeah, sure. I can just Sorry, I'm a bit slow at this. Yes. Going back to the chat. Can we get link for the site? So Rudolph says, I'll post them soon. You happen to have a link where we can find all open source libraries for data science? Not sure, but if I can share the link of the slides, you can always like Google them up. I guess that would be it. So this is, can you please share the name of the book again? For sure. So this is the link, and the book is known as Sculpting Data for ML, the first act of machine learning. How do I send it to all? Yeah. So if you're someone who likes like data science and feature engineering and data pre-processing and transformation, before like obviously we do talk about models in the last chapter, but initially it's more about like code examples in Python, how to like create your own data set if you don't want to use, and these are based on like a real life data sets that we put up on Kaggle, and they've received like lots of love. So yeah, definitely check it out and look forward to your feedback. Yeah, questions. Actually, you know what? I can just download it as PDF and maybe send it right here.
There's also some questions in the Q&A. Do you see those?
Oh, okay. Yeah. Sorry, I didn't. Yeah. So I was just trying to share my. I just shared the slides. If someone's interested in, like, I shared like a PDF, and I'll go back to Q&A. Okay, can we get the link? On Rudolph, I just posted the file itself on the chat. Marcus says solutions for graph-based data rather than tabular data, mining graphs, clean and convert into tabular data from Pandas slide. Oh, okay. So I'll be like very honest. I haven't like mentioned about tools, which I haven't used them personally. And personally, I've always worked with tabular data. So I might not be like someone who's like good enough, kind of like to recommend solutions for graph-based data. I hope you understand that. Yeah, and Sharp Saurabh Sandar, she says, you talked a bit about observability with Tensorflow. Could you talk about tools for other observability tools? Example, tools to extract load metrics, specifying dashboarding tools, etc., especially in production since data science. Yeah, of course. So I can talk from my experience. So currently I've been using Kubeflow with GCP, and I think it has like a nice platform for like nice dashboard to load and extract tools. So not only I can see my entire pipeline in there, like GCP and Kubeflow, like in conjugation, and it also it's good in production because it's something that we're using, and you can always see metrics online. So that is something that I'd recommend. Yeah, I hope that answered all your questions. Any other questions that I could help with?
Question just came up in the Q&A.
Okay, is it possible to do machine learning and building without actual coding? So, Selena, I would say it is like, as I said, like there are programs like Weka, you could get started with machine learning if you want to just like feel out how it feels, like, how it would work and all. But in all honesty, if you want to do like lots of customization and, like really grow forward, coding is something that I would highly recommend. You could do like a bit of like data analysis and all with like SQL, where you don't require a lot of like programming skills, but it's definitely you have an upper hand if you can learn programming. You can, start to maybe in parallel, like start with GUI and like learn the basics of machine learning and like data science. But when you have to like grow further, coding is definitely that will come in hand, because you'd have to do like a lot of customizations and tweaks here and there, which pre-built-in tools might not allow you to do that. I hope that helps. Would you share your experience in dealing with the pace of machine learning field? It moves quickly. Yeah, that's actually so true. So one of the one of the things that I would suggest doing is like when you work somewhere or when you are a student, always like focus on the basics, that's for sure. But you can, maybe try joining a group, like a reading group or something, where people do like research, readings, and so on. And like that's for us, like for me at work, that's what has helped, because people, like for new concepts that come up and new research papers, they'll share. So you don't have to like read every paper on yourself, like by yourself. There would be someone who'd explain the idea. And if you find that idea interesting, you could always like go ahead. But yeah, definitely it moves really fast and it's difficult to keep up. But sometimes it's okay not to like grasp everything that comes your way. Like take it slow and like filter whatever you need and whatever like suits you and whatever interests you the best. So totally fine. And Selena says, do you know any website or courses to take to learn Python? So to learn Python, I would recommend the Python documentation itself. So for the basics, that would be really helpful. And for example, if you want to do like try going with some projects, if you want to do like online courses. University courses are nice, but then again, like websites like Udacity or edX, they might help. I can try finding a few from my end and help, but it's been like long since I started Python, so not sure. Yeah, I can try looking them up, but yeah, again, my knowledge would be as limited because it's been a lot of years since I started with just Python. Could you also talk about model training and serving? There are some managers like SageMaker and AutoML, but would love to know some open source alternatives, your experience with them. Hi, Saurabh. So I do not have experience with like automated managed services like model training and serving, because the field that I've been currently working in, we've been trying to do it ourselves. So I would have, and they are not open source at the moment. So would have shared if I would have any, but yeah, currently no suggestions regarding that. Sorry. Do you have recommendations for libraries for doing ML with, say, connected vehicles? Not really. Like, again, as I said, I only share the tools that I have experience with because, yeah, it's easier to answer questions regarding them. But yeah, I don't have any, like, I haven't checked them out, like, for vehicles, etc. But I believe OpenCV might be helpful, because when you're kind of like driving cars and stuff, you need to do object detection and stuff like that. So maybe getting, like, if you're just getting started with that, that might be like really helpful library to look at, but yeah, not further than that. Yashil says, hi, Yashil. Joanne says, the only link I see is the link to your book on Amazon. I greatly appreciate, but that do not link. Can you please? Oh, can someone confirm that I have sent the file itself on the chat? Yeah, let me just confirm, because I thought I just posted an entire file as it is. Oh, got it, Marcus said, yes. Okay, cool. Yeah, she says, any free documentation or documentation that you found helpful to start off with machine learning? Sure. So as I said, things that I found interesting while machine learning, especially the first half, would be like, I documented in my own book. So if you'd like to check that out, Yashil, because all the things that I learned from were from various different courses, my school projects, and tutorials and all. So I've like documented them in my own book. And the first 4 chapters would be heavily inclined towards data, because that's what I feel as well. Like how good your model is dependent on how good your data is. And then the last chapter gives you like a brief overview of like all the different kinds of machine learning models that you have and what kind of data would suit you the best. So yeah, that is something that I'd recommend. Alternative. Yes. Yeah, thank you, Mark. Yeah, thank you. Joanne, I hope you got the slides now. It would be great if you could like let me know so I can share again. I'll just share it again. Oh, I tried sharing it again in just panelist. Yeah, otherwise I'll just like host online and like ask Todd to like share it in a newsletter or something like that I could do. Oh, yeah, did you get, sorry if I'm pronouncing everyone's names wrong, but yeah, did you get access to the slides? Because I did post it. Okay, do we have more Q&A? I think it's mostly done. Yeah, I think if it's not working, maybe I'll have to like ask someone to like send it over as a link when I host it. So yeah, sorry about that, folks. Wish I could send you. If you like, send me a, yeah, maybe connect with me on Twitter. Perhaps I can send you later then. Sorry, folks, I haven't hosted them yet. So what is the best programming language? So I talked about in my, just in the presentation that I would say Python, like I would highly recommend Python. So yeah, that is something that I would recommend. You could get started with R, but then if you look at all the libraries and frameworks that we've talked about, and which are like mostly popular and people use it in the industry as well as in research, academia, Python is the way to go. Oh, strangely, I don't know why it doesn't show the file I have. Yeah, sure. Yeah, I'll DM you. Yeah, don't worry about that. Do you think Ruby can incorporate scripts into machine learning? Yeah, I believe like they can, like for sure. You can do like cross-platform integrations, but once it's easier for you to do like everything in a language, I believe, because especially like not building like a very high-tech system, like you're not doing like a huge pipeline, let's say. You're not doing, for example, when at work, we do use like a lot of languages to do like a lot of different tasks and integrations. But when you're just like starting out and trying out different things, definitely Ruby can incorporate. But then having something that Python can do, which Ruby also does, would be great on your end because you would just like hone up programming skills in that language and help you with integrations, like save you some time. Thank you, folks. That is time. Yeah, good seeing you. E-meeting everyone. If you and definitely send me a message on Twitter or you can find me on my website. And if you have any questions, feel free to reach out, and I'll see how I can share my slides. It's been a tough time though. Cool. Thank you so much, everyone.